Hello, 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 hello. Hello, 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 hello. That was 4 hellos plus 4 more there. 8 hellos. How is it going? What is up? It's your boy M Spitz coming at you live. Chapter 8 quiz review. But actually, it's 5.7, 5.8, even though we group it with Chapter 8. So it's the Chapter 8 quiz, but it has no Chapter 8 in it. So I don't know. I do know. It makes sense. Okay. So I figured I would just start with and just sort of go through example problems, right? I'll do problems from the homework, but I'll just select them so that we get a variety of sort of each type. There's only 2 sections, right? So there's really not a ton of stuff to flat out remember. I mean, you need to know the Pythagorean theorem, a squared plus b squared equals c squared, your special right triangles, um, and all that jazz. Actually, you don't need to know any jazz. So those musicians out there, don't worry about that part. All right. We got 2 people in the chat. You know who you are. Great work. I'm sure those people already liked, so that's good. Anyway, so I'm just going to sort of pick a couple and sort of as we go here. Sound good? All right, first problem. If we're looking at, there's only 2 sections, like I said, but I'm going to try to pick problems at least cover the variety. And if you have questions on these problems, I will be happy to oblige and go over any of those. All right, but as far as right now, I am going to look at this question here. So this question, what color? I say blue. Yeah. All right, so again, I'm looking at this. I spot this. It's a right triangle. My first thought is Pythagorean theorem. If you have sides of a triangle, I'm thinking Pythagorean theorem. Can I write an equation out of it? Can I do something with it? Again, I don't know, and I would never assume because it doesn't even give me an angles. Like there are no angles, so I wouldn't assume 30, 60, 90 or any of that stuff. Or 45, 45, 90. I would just do Pythagorean theorem. All right, so of course, again, this is my first time doing it, so I'm just going to make sure we write it out so we understand that A, B, and C, sides of a triangle. C is the hypotenuse, the longest side. It's always opposite your right angle there. So in this case, here's my right angle, boom, opposite. So of course I know that in this case, x is my c squared, and I'm just going to write the equation, right? So it's going to be, and then a and b don't really matter. They're just the 2 legs. So blue is the color of math. I kind of agree with you there, and I don't know why. Anyway, so we're going to get 8 squared, right? That didn't really seem to affect anything when I lowered the size. All right, 8 squared plus, and then this is the tricky part. Not tricky, just make sure it's x minus 2, the whole thing, squared, equals c squared, which is just x in this case, right? So now we have an equation all with x's. All we have to do is sort of expand here. So we get 64, and then we do have to FOIL, right? So we're going to be x squared minus, then it's going to be minus 2x, right? Because it's going to be this. Just if you need to visualize it, go ahead and write it down. So x outer, first x squared, outer is negative 2x, inner is negative 2x, which means negative 4x is going to be when I combine them. And then of course, negative 2 times negative 2 is positive 4 equals x squared. All right, so now it looks like I have some quadratic action, but I don't, because when I subtract x squared from both sides, it goes away, which is beautiful. It's a beautiful sight. All right, so all I have to do basically, we have negative, how about this? I'll just combine these to get 68, and I will add 4x to this side. This was 0, there's nothing on this side, right? But I'll add 4x to this side, so we get 4x equals 68, right? So what do we get? A value 17, I believe. I think that's 17. All right, so we get 17. So x is 17. And again, if I just wanted to label all the sides, like it asked me for x, right? I don't remember what it asked me for. Zoom, backs. Okay. I figured, but hey, you can't be too safe nowadays. All right, so it asked me for x. I found x was 17. If it asked me for the sides, if it asked me for the perimeter, if it asked me for the area, right, I could do more, but I'm just going to plug that back in because I know what's good for me. How come I can't scroll over? What's the deal? All right, I don't know. Anyway, x is 17, which means this side is 17, this side is 8, and this is 15. Oh, look, it's one of our triples, guys. It's one of our triples. We should know our triples. Again, not that I would know that going into that. There's no way for me to know that that was an 8, 15, 17. I wouldn't have assumed it was a triple or anything. So don't look at that. But after it's all said and done, it's like, oh, cool, makes sense, totally. All right, so sounds good there. I love it. I love that problem. All right, high five the screen if you got it right. Don't be shy. It's fine. No one's watching. It's cool. It's cool, man. Everyone's doing it. Yeah, that's right. Good one. Nailed it. Boom. All right, good thing I wasted time doing that. All right, so let me take a gander at some more here. All right. Yeah, I mean, here's a problem that's just sort of straight up Pythagorean theorem, and again, there's a reason why it says answer in simplest radical form, right? It may not be a triple, it may not be nice numbers, it may be something where we have to simplify radicals. Simplifying radicals is a thing we have to do. Bring your calculator, right? Make sure you bring your calculator. That was the bring. That's what I should make. I need to bring your calculator music video that's like graphics. Bring your calculator. Something a little more like that's what I need as well as a video that I can play now to remind you, like maybe an on-screen graphic. I don't know how that works, but someone might be helping me out with that. Okay, anyway, so yes, we're thinking Pythagorean theorem. So we have a squared, b squared. We know this is going to be our c squared in this case. So we get 3 squared plus 9 squared equals x squared. All right, so we get 9 plus 81 equals x squared. So we get 90 equals x squared. We radical both sides. Again, I know this is quick, but we're okay now because the hardest part here was not putting it in and doing the radicals and figuring all that out. It's sort of simplifying this radical. I mean, I would say this one's not so bad because I know 9 goes into it pretty easily. Like it ends up being radical 9 times radical 10, right? Which is radical 90. And of course, radical 9 is just 3, and radical 10 is just radical 10. So there it is, 3 radical 10. Love it. All right. If you and again, you cannot get these problems wrong because you can just plug them in and square them. Like in other words, like what is 3 radical 10 squared? Well, it would be 3 radical 10 all squared. So this would be 3 squared, which is 9. This is radical 10 squared, which is 10. So 9 times 10 is 90. Boom. I plugged it right in. It worked. All good. Remember, just make sure when you're squaring a radical that you square both of these things. And when you square a radical, it sort of cancels, right? So it's 3 squared times radical 10 squared, which is just 10. Right? Right. Righto. All right. Then you get some other, and again, let's see. There's one that involves a few more triangles, if we may. All right. So let's just say we did a little something like this one. All right. This is a nice one. Some people, I hope it wasn't you. You know who you are. Yeah, looking at you. Some people might be like, oh, look, we're trying to find this, and we have this triangle here, and we have two sides. So just 7 squared plus 10 squared equals x squared. And that would be that would be what's known as taking an L. Okay, I'm not sure if you guys have ever heard that before, because I think I just made that up right now. I don't think anyone's ever said that, but that's what I'm going to refer to as taking an L. Don't do that. 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 I'm actually afraid someone's going to watch the video quickly and do that, but don't do that. All right? So, take W's. Is that a thing? I don't know. Wait, why can't this erase? Come on, erase. You can do it. Now I got this big L on my screen. All right, I don't know what the deal is. Oh, it's only working when I don't use the mouse. All right. Blue's the color of math. Blue's the color of math. Blue's the color of math. Boom. Now it's got to be Gator blue. Okay. So don't do that. And I say that because it's not a right triangle, right? We do have 2 right triangles here. Of course, if that's a right angle, so is that. So we do have 2 right triangles. But really, in this case, just solve what you know, right? Solve what you know first. So if we look at this triangle over here, this one's pretty easy because it's like, hey, we have 6 squared plus something squared. And again, I can't call it x because x is the whole thing. But what if I just call it like a and I'll call it like b, just so if I want to put it in there, right? So a squared equals 10 squared. And this is where I stop and go, oh, this is a 6, 8, 10. All right, this is a 6, 8, 10, so this side is 8, right? Like I don't have to do, but I know that that's a 3, 4, 5 times 2. If you didn't, of course, you could go ahead and solve. It's 100 minus 36 is 64. Radical 64 is 8. We got it, totally. But So I'd rather have you get it fast with your triples. But next thing would be to get it and not miss it, right? Just get it, period. All right, so now we have that. That's 8. Well, how does that help? Well, because now I know that this x is 8 plus something, which I can find, right? In this case, we have 6 squared plus b squared equals 7 squared, right? Because now we have this. You can't really see what I wish the mouse cursor would show up. I don't know why it doesn't. Anyway, we have this sort of triangle, over here, right? This one right here. And so I can just say that's a right triangle as well, right? So we have two right triangles. We're just going to use pieces of both of them, or maybe they overlap. Maybe you find one and then subtract from the other. Like there's a lot of ways that they can interact with each other. Maybe the side of one that you find ends up being like the hypotenuse of one becomes the leg of the other. Maybe we'll do it like that too. But anyway, we solve this bad boy. We get 36 plus b squared equals, what did I write there? You know what I did? It's 7 squared. I wrote 7 squared and thought 49, so I ended up just talking and writing 7 9. If you're saying that in the chat, cool. I'm not looking at the chat right now. It's behind a menu. So if you were yelling at me, then you were right to yell. Okay. Sorry, my fault. Anyway, 49. So we get b squared equals, looks like what, 13, and that's prime. So it's just going to be b equals radical 13. So this is radical 13. So then what is x? Well, it's 8, which is this, and radical 13, which is this. Add them together. Can't combine them. So 8 plus radical 13. I love every second of that answer. All right. If it happens to be even, awesome. Even better. Combine them. If it happens to both be radical 13s and you can combine them, by all means. But if there's one and the other, you can't combine them, right? They don't mix. Oil, water style, right? Yeah. It's like oil, water, Daniel not being on his phone. Like they just don't mix, They just don't mix. Okay. That's what's known as like throwing shade. So if you need to know these terms, again, I know I'm teaching you about the lingo of today. All right, so let's take a look at the chat. Is there anything? Yeah, there you go. See, someone called in the chat. I knew they would, but we're good. Okay, yeah, good job, Alyssa. All right, so I'm looking. Keep on looking. All right, so let's look for another maybe theorem question. Okay, so ones that involve multiple, again, like, I don't know, let's look at a little something like this. All right, so I'm thinking, okay, to find x is part of this right triangle here, but I don't have enough size to find that, and I would never assume that it's isosceles right triangle or anything. Like I just wouldn't. There's no way for me to know that, so I wouldn't assume it. Okay, but I can look at this triangle right here, right? And I can be like, oh, this triangle with the star, right? And I can be like, oh, that I have two sides of. So I can use that to find this side, and then use these two sides to find what's missing. So it's a case of two Pythagorean theorems. All right? Two is better than one. Like that's a thing. People know that. But let's say, so 7 is my hypotenuse. That's the only thing to be careful of. Make sure you know which one's the hypotenuse, right? So it's going to be 2 squared plus, I don't know, we'll call that y squared. I just didn't want to call it x because it's already down there, right? Okay, so 2 squared plus y squared equals 7 squared, which is, I wrote it correctly this time because I'm learning. So we get y squared, that's going to be 4, that's going to be 49, so that's going to be 45, right? I mean, 49 minus 4, 45. So then radical 45 is y. And here's a little trick here that I got for you. I could simplify radical 45. I could do that. I totally could. Okay? And if I wanted to, it's 9 times 5, so it's 3 radical 5. I totally could do that, and that's cool. But I'm not going to, because I know what's coming. Because I know what's coming next. I know that this side is radical 45, right? So it's like, what am I doing? What's my next step in this problem? It's to do 5 squared plus x squared equals radical 45 squared. And so it's easy to square radical 45. It's just going to be 45, right? I mean, so that's why I'm thinking ahead a little bit, big brain, people call that. Kevin does at least. I don't know if that's what real people say. Anyway, x squared plus 5 squared equals radical 45 squared, which is nice that when I square that, it becomes 45. This becomes 25. And then when we subtract it, right? We get 20, so x equals radical 20, right? Just radical. Okay, and that's 4 times 5, so that's 2 root 5, right? So x equals 2 root 5, which is a lovely answer. Again, if you wanted to do the same thing and you ended up making it 3 radical 5, that's fine. That's perfectly fine. The only thing you want to make sure you're doing is when you square 3 radical 5. Oh, it's my, I'm in the way. Whoop. Okay. The only thing you want to make sure you're doing is when you square 3 radical 5, that you square the 3, square the radical 5, so that's going to be 9 times 5, which is equal to 45. So it still ended up being the same thing. I just saying, if you know what was coming, you could think ahead, right? Want to be one jump ahead of the problem. That's not how the song goes at all. All right. Actually, one step. I don't know. Doesn't really matter. Okay. And then you really should know your triples, right? So the basic ones, right? And these will help you, right? So we just want to review what the triples are. So just so we know, right? We know 3, 4, 5, and sort of any combination of 3, 4, 5. In other words, that would be 6, 8, 10 is a super common one because that's just those 3, 4, 5s doubled, 9, 12, 15, which are just them tripled, right? And so on, right? If you get a 30, 40, 50, right? Those are pretty easy to spot, right? Like I'd say like memorize these, maybe try to spot the other ones if you can. Okay? So that's one. Then we have 5, 12, 13, right? 5, 12, 13, and of course that would mean 10, 24, 26. I'd say if you just remember this one and then know the multiples, you should be good. Same thing with 8, 15, 17, right? Know the multiples if you want, but remember those. And then the last one is 7, 24. Okay, I say the last one that we're going to memorize is 7, 24, 25. And of course, you can double and triple and all that for all of them, but that's the idea there. So if you know those, it'll make things a lot easier bouncing around triangles, right? And again, if you just take a look at some of these questions, it's like, this one would be a tricky one because it's like, it looks like 6, 8, and so it might be 10, but it's not, right? Because it's the only thing to make sure is that the hypotenuse is the longest side. And that wouldn't be the case here. But 8, 15, 17, that one we get right away, right? So it's like, hey, look at a free question. Okay. So that's good there. Great. All right, so then the other thing that we can do with Pythagorean theorems, this is the converse of the Pythagorean theorem, would be if we can tell if our given 3 sides. So if I show the 3 sides to you, probably not. But if I just give you the 3 sides like so, right here, we have those sides 10, 12, 15, and we can tell if it's acute, right, or obtuse. And we can do that. I'm reading the comments and I don't really know where to go with that, so I'm gonna not comment on that. I can answer Samantha's though, or I don't know who calls you that, but Sam's, and that would be basically um, why your question was what's the point of triples? The point of triples is sort of they're so common. Like you see the same set of Pythagorean numbers working out all the time. You see a triangle and you see these sides and they're adding up and you see them over and over again. So it's like instead of me doing Pythagorean theorem on something, I can just know it, right? I can just know for a fact that if I have the two sides, the two legs of a triangle that are 8 and 15, I know the third one's 17. No math required. It's just memorization purposes. It's for speed. Um, you know, sometimes going for speed, like um, the fastest animal, the falcon, which can go, according to Google, 240 miles an hour. So there you go. That was a comp sci fact today. Anyway, all right. So if I'm doing something like this, the main thing is this one has sort of a caveat. It says tell if the measures can be the side lengths of a triangle, right? So we may end up one that doesn't work out. But basically the idea is if we're all looking at c squared, because if c squared equals a squared plus b squared, right? So I do this calculation, I get c squared, and it's equal a squared plus b squared. I can then tell you it is in fact a right triangle, okay? But if c squared is bigger, right? So if c squared ends up being bigger than c squared, than a squared plus b squared, then it's obtuse. And if c squared is smaller than a squared plus b squared, then it's acute. So the idea is just you know C squared C is going to be the biggest side, so we square them. So I'm just going to say, oh, here's my biggest side. 15 squared is 225. 12 squared is 144. 10 squared is 100. So this is 244. So in this case, I'm comparing this to this, right? 225 is C squared, right? This is C squared, and this is A squared plus B squared when I'm solving. So it's like, okay, 225 is less than 244. So C squared is less than. So if C squared is less than, it's acute. I mean, the perimeter and area questions are good because they sort of incorporate a lot of stuff in these questions, right? Yeah, 100%. Well, you should. I think I'll probably come back to one of those, to be honest. I just had an order that I was writing down things to do, and it might be in order. So, okay. The question was, when is it not a triangle? Well, this one would be the case of it not being a triangle. Because remember, the triangle, the two smallest sides have to add up to be bigger than the third side. So if I add those up, 21 is not greater than 23. So like this one isn't even a triangle. No triangle, right? So, all right. Yeah. So again, just the main thing is find C squared, find A squared plus B squared. Again, if they're equal, boom, it's a right triangle. If C squared is bigger, up to C squared is smaller, acute. Good. Remember that. Put that in your brain. Yeah. Good job, Vin. Okay. I think we're good there. Let me just. All right. I know there's always there's. I'm gonna use this blank space here, but there's always. Well, let's go. Let's just go into 45, 45, 90, because there's a couple situations that I said that happen a lot, right? Um, Another way that we were looking at this 45, 45, 90. Another way to describe a 45, 45, 90. I mean, let's just put it this way. If you know you have two angles that are the same, you know you have two sides that are the same, and if two sides are the same, you know you have an isosceles triangle, and if one of the angles is 90, it's a right triangle. So a 45, 45, 90 is always an isosceles right triangle. So it's like you could describe it, you could have a picture, right, that showed it as isosceles and right, and I would know that this is 45, 45, 90. I talked about having half of a square, diagonal of through a square makes two 45, 45, 90 isosceles right triangles, right? I use those terms interchangeably, and you should sort of be aware of that. And so that would be a job where, let's just say we have, let's just do this one, right? So I said, hey, find the perimeter and area of each figure. So this is a 45, 45, 90 triangle with a hypotenuse length of 12, right? So we know that this 45, 45, 90, it could have said an isosceles right triangle with a hypotenuse of 12. Like that would be the same thing, right? But we're trying to find that perimeter and area. We didn't give a whole ton of room to you here. Just zoom in on your paper and you should have plenty of room. Sounds good. Cool. All right. So again, I might sketch this out. And I definitely would sketch it out, right? So we get a little right triangle. We know it's 45, 45, 90, and the hypotenuse is 12. All right. My next step is I need to know 100% 45, 45, 40, this 45, 45, 90 special right triangles. I need to know what their side ratios are. And again, if I said it was 45, 45, 90, opposite the first 45, I'm going to call S. Opposite the second 45, I'm going to call S. They have to be the same because they're the same. And then, of course, opposite the 90 is S times root 2. All right, so there are my ratios. And what I'm going to do is use that. I'm just going to label my diagram. So this is S, and this is S root 2. So what I should do is find the side that I know two things about. So 12 equals S squared equals. And so there's my equation, right? I can go ahead and I can do that math now. And I can be like, yep. So I just divide both sides by 12, or sorry, by radical 2. So 12 divided by root 2, that's my S. And then to rationalize it, because I can't leave it like that, rationalizing it just means getting the radical off the denominator, out of the denominator. And so I just multiply straight across, and I get 12 root 2 over 2, which 12 over 2 is just 6, so 6 root 2. And again, there's a thing that we see, and again, hopefully you did enough problems to realize that if you have an even number as the hypotenuse of a 45, 45, 90, the sides are going to be half of it root 2. I mean, that's we've done. Hopefully, you've done enough that you recognize that, and if you do, awesome. If not, do the work. It works out every time. All right, so here are my three sides of my triangle. I need 6 root 2, 6 root 2, 12. So to find the perimeter, I add up all the sides. So that's 6 root 2 plus 6 root 2 plus 12. I can only combine two of these, right? I can combine 6 root 2 and 6 root 2 to 12 root 2, and 12 I can't combine. So my perimeter is going to be 12 plus 12 times root 2. Right? That's my perimeter. And I guess that's in, I don't know, inches, I think it is. So that's going to be in inches. The area, we know area is pi, or is 1/2 base times height. So in this case, my base and my height of a right triangle are always the legs. So I have my legs are 6 root 2 and 6 root 2. So our area is going to be 1/2 6 root 2 times 6 root 2. This is the same thing as 6 root 2 squared, if that makes more sense, but we can still do the same thing. So I think we did these as an example, but anyway, 6 root 2 times 6, or sorry, 6 times 6 is 36. Root 2 times root 2 is just 2. So now we have 1/2. I just brought down the 1/2. 1/2 times 36 times 2. That's just going to be 36. So my area is 36 square inches. Right, my point is that 45, 45, 90, you can combine things, perimeter and area is good to know. Another common situation, so the next one, right, and again, if we were recapping here, the next one would be to look at 30, 60, 90s and understand what they are, and they have they're like right here. Okay, so now you can see the cursor. Weird, when I use the mouse, you can. Okay, so we have opposite. So we have 30, 60, 90. And again, this is the way I said to remember it. Again, you can remember it however you want, but I think this always works because opposite the 30 is S, opposite the 60 is S root 3, opposite the 90 is 2S. That's like the minimum of knowing things, is knowing the special right triangle like ratios, like actually knowing what they are. And then next step would be able to put them on the diagram. Again, opposite the 30 is S, opposite the 60 is S root 3, opposite the hypotenuse is opposite the 90 is going to be 2S, right? So you label them, and once you label them, we're good to go there. A common situation for us to get a 30, 60, 90 triangle is if I have a equilateral triangle. I said this in class as well. But if you have an equilateral triangle, we know that that's going to be 60, 60, 60. So it's not a 30, 60, 90 triangle. But if you take the height or altitude, same thing, right? What that does is it makes a 90-degree angle and splits this into 30 and 30. So we end up with two 30, 60, 90 right triangles where then I could work on one at a time to figure out what I need, right? So we can take a look at an example that we would use that. So let's just say we have an equilateral triangle with side length of 4 feet. And so it's asking me for the perimeter. Well, actually, that's kind of easy because if I'm going to sketch this out, I mean, the first part is it anyway, because I know it's equilateral, 60, 60, 60. So it's going to be 4, 4, 4. Oh, well, so the perimeter is just 12. Okay, so that was the easy one. That was the easy part. The area is going to be the rub here. The area is going to be the trickier part. Um, so, okay, so the area, again, there's no height here. So what I should do is I should draw a height in. And what that does is it does a couple things. One, makes a right angle. We know that's 60. We know that's going to be 30 because it splits that 60 in half. We know it's actually splitting this bottom one into pieces. So it's 2, right? And 2. Okay, and so we need to find the height here, and we can do that because now we have a 30, 60, 90 triangle where this is 2, that's 4. So we actually know if I label my sides that this is S, that's S root 3, and that's 2S, right? So if that's horribly written. So if S equals 2, well then S root 3 is just 2 root 3. So that's my height. My height is 2 root 3, and then this is the height of like this, that what I just found is the height of the triangle, right? It's the side of this triangle, but it's the height of this triangle. I just used the 30, 60, 90 triangle to find the height of this overall triangle, this overall equilateral triangle. Okay, so now we have our area is 1/2 the base. Well, in this case, the base of this triangle is this whole thing, which is 4. And then the height we just found, right, which is here, it's 2 root 3. So remember, if I have a root 3, just one of them, I can just sort of almost ignore it and bring it back at the end, kind of like if it was x or something. So we have 1/2 of 4, which is 2, and then 2 times 2, which is 4. So we end up with just 4 root 3 is my area, and that's square feet. Make sure you put units. All right, so the perimeter was pretty easy because they gave me the side, but I'm using that to find the height, which I need to find the area. All right, does that Makes sense. Someone checking the comments now. Okay, no one said anything. Cool. All right. And again, you're gonna, of course, have to do we did a bunch of these like this on the Kahoot today, but these, of course, are just uh, I mean, they're straightforward in that they're showing you it's 30, 60, 90. It gives me one of the sides, and I have to find the other two sides, right? I mean, but we always can do these because we can be like, all right, well, opposite the 30 is s, opposite the 60 is s root 3, opposite the 90 is 2s. Oh, s equals 1. Those are the thing. That's the side that I know two things about. Set them to equal to each other. No solving required in this one. So if that's s is 1, then 2s is 2, and s root 3 is just 1 root 3 or root 3. So it's like y is root 3 and x is 2. Okay, not so bad, right? And we can do these for almost all of them, right? We did a ton of these. If you just make sure you're practicing and practice all these and check your answers, you should be good there. Again, first step, make sure you know the ratios, right? The 30, 60, 90 and 45, 45, 45, 90 ratios. Know when you're using them, and then be able to label the size. And from there, it's just a matter of, am I doubling it? Am I multiplying by root 3? Am I dividing by root 3? Am I taking half of it, right? Am I multiplying by root 2 if it's 45, 45, 90? And you can do all that just by labeling the sides, figuring out which side you know two things about, and boom, making them an equation that you can solve. All right, love it. Yep, bunch of those. Make sure there's 1, 2, 4, 6. There's 8 of those. You just gotta know. And then you get some tricky ones, maybe like, which again, maybe, I don't know, let's try like this one just because it's oriented, right? We might be able to sort of see it in this way. Again, we can, let's just try to get all these. I think this one, it didn't actually, for whatever reason, it didn't show the, it didn't actually show the answers on the key. So let's just do this one all the way. And again, I would look at this and be like, oh, I have a right triangle here that says 45. Okay, I have a right triangle here that says 60, which means that's 30. We knew that was 90 already because that's the other side of that 90. All right, so far so good. Okay, now we know we have a 30, 60, 90, so let's label our sides here, right? So we have, okay, opposite the 30 is s, opposite my 60 is s root 3, and opposite my 90 is 2s. And then I'm looking, I don't have anything. Okay, so let me go to the next one. And again, here's the tricky part. Because they share that side, right? They're sharing this side. Like, this side for this triangle, because that's 45, this is going to be sort of my s of this triangle. So maybe better for me to use another variable. I'm going to use a different color. So like that's not so bad. But the idea is like for this triangle right here, right? For this triangle right in here, it's, I'll just make him blue. That this is s, and this is s root 2. So it's like, okay, well, s equals 5. So that means this side equals 5. Which I'll just turn that into a 5. Right? So we have 5 and we have 5 because those are the same, and that's 45, 45, 90. That means this y is 5 root 2. Okay, so we actually got a couple of variables already. X is 5. Y is 5 times root 2. Okay, so now we have this 5 on this side of this triangle. So now we're sort of looking at it as just sort of a whole separate triangle, a whole 30, 60, 90 triangle this time. So now I'm thinking, well, 5 equals s root 3. Okay, so in this triangle, 5 is in this format s root 3, which I can solve for s, because I have to solve for s by dividing by root 3. And then we get 5 over root 3, which I have to rationalize. So it's going to be 5 root 3 over 3, right? So that's what s is going to be. And this s, though, right? The s from this other one. So this is going to be 5 root 3 over 3. So that's what z is 5 root 3 over 3. And then 2 times that is just going to be 10 root 3 over 3, right? Just double the numerator there, double the coefficient of the numerator. Just essentially it's multiplying it. It's like 5 root 3 over 3 times 2 over 1. So we just multiply across, and that just turns it into 10. Okay, so it's like we had to use both of them, but sort of keep them, even though they share that side, right? And that's what's going to tie them together. Solve what you can, because you're given, I was given this 5, so solve what I can with that 5 root 2. Then use that fact to sort of tie them together. And and I think you should be okay. All right. There's no 5 on this page. So I don't, unless I was on the other page when you asked me this, I don't know. Elaborate. I don't see number 5. So okay. What else? What else? What else? I mean, that's kind of it, honestly. That there's only 2 sections, and while they're super useful, you're gonna use them, throughout the rest of the year. So it's almost like it's sort of important that, of course, that we know these 2 sections. Pythagorean theorem should hopefully be kind of instinctual. If you spot a 60-degree angle, you should be thinking, I need to get a 30, 60, 90 triangle because I know how to deal with that. And the good news about when you have special right triangles, either 30, 60, 90 or 45, 45, 90, is that you only need one side, and then you give you all of them. Buy one, get 2 free, right? As opposed to typically Pythagorean theorem, it's like 2 sides to get one side, to solve for one. But again, we did a bunch here. Again, there's certainly some other ones that you should have had these done anyway, but practice them again. Make sure you're coming up with the right answers. There's plenty of practice you can get. We're not there yet. So again, make sure we know those. Make sure you know the ratios. Again, if you sort of could do the ones that I did or similar ones to them, I don't see how you could. Um, I see only good things. And in fact, the better you do, the easier it is for me to grade. So if you could just do me a favor and just get them all right, that'd be cool. Thanks. All right. So 14 was a question. I don't know. So if I'm looking at 14 here, so the first thing I notice is that this isn't a triangle. Okay, but that should be a clue here. The 60 degrees should also be a clue because this is a section about 30, 60, 30, 60, 90 right triangles. So let's make a 30, 60, 90 right triangle. And I can do that by just sort of going from here, and just sort of making a height here, basically, essentially. But that's going to be a right angle, which means this has to be a right angle. So like that's a rectangle in there. All right. So now I actually made myself. This is a nice one, pretty nice. A 30, 60, 30, 60, 30, 60, 90 special right triangle, right? I made myself one. Now I don't have any sides yet, but because this is a rectangle, right? And we know about rectangles have opposite sides are congruent. So like if that's 2 root 3, then this is also 2 root 3, right? And if that's 2 root 3, then, well, I should label my sides, right? So they're going to be across my 30 is S, across from my 60 is S root 3, and across from my 90 is 2S. Okay, and so let's use like a dark green. All right, so well, hopefully we see that if 2 root 3 equals S root 3, then the 3's cancel and S equals 2, right? So we know that this is 2 right here, and this would be 4 right here. So we just basically found A was 4. So how do I find B? Well, some people might be like, oh, B is, it looks like it's opposite 5, but it's not. Like this whole thing, right? This whole thing here to here is 5. If this piece right here is 2, well, what does this piece have to be? 3, because 3 and 2 is 5, right? The whole thing is 5, so and we already found that that was 2, so I subtract it, and then that's 3, and so the opposite sides of this are going to be congruent, so B has to be 3. So all that for A being 4 and B being 3. Yes, you see if you see a 60-degree angle, you're thinking, I got to make a 30, 60 degree, 30, 60, 90 special right triangle. I have to make one. I should make one. Just like, hopefully it's kind of instinctual. You have a square and a diagonal of a square, you're thinking 45, 45, 90 triangles. If I have an equilateral triangle and I somehow need the height for either area or just because maybe they give me the height, then I should know that that's 60, that's 30. And then as long as you know that opposite the 30 is S, opposite your 60 is S root 3, and opposite your 90 is 2S. Then you plug them in the right spot, solve, blam, blam, blam. Well, I mean, there's a whole section about that we talked about proving whether, like, what kind of shape it is. And the only thing we know right now is that it has 4 right angles. So it's a 4-sided figure, right? Like what we know is it's 4 sides with 4 right angles. I mean, we don't know anything about the side, so we just can assume that it's at least a rectangle. It's possible that it ended up being a square. I just didn't know that at the beginning, right? So based on sort of this criteria, we would have had to known that it was only at least a rectangle, but a mere rectangle. You know, it could be more. Um, and again, once you actually solved it and recognized that if this is 2 root 3, then that's 2 root 3, then you solved it and recognized that, of course, it wasn't a square because that's 3 and that's 2 root 3, right? So you actually ended up proving in the end that it wasn't a square, but but you could prove it was at least a rectangle. So we did. Degerts. Go get your just degerts. Just desserts. Not that good. I'll work on it. It's okay. Average at best. Okay. Um, how we how are we feeling? Good? Great? Grand? I'll wait 1 second for questions, comments, concerns. Just checking on something. All right. I'll wait around for some questions while I. All right. All right. Just give me 1 second. 1 second. I gotta check on something. But I will do number 34. But I will do number 34 and 5.7. All right, sorry. Um, I'm back. I know that was longer than what was I looking at? Okay, you said number 34 and 5. 34 on 5, 7. I think I did 34. What? Oh, it's down here. All right. I mean, there's a couple things we should hopefully notice is that this is 5. This is a right triangle, first of all. 5 and 13. So I know that that's 12, right? If that's 13, that's 13. So if that's 13 and that's 12, that has to be 5, right? I mean, obviously, we probably could have got that from the isosceles triangle part of that. Um, okay, and now it's basically a problem that we kind of had before, right? Where we, oh, okay, cool. Where we end up with like this right triangle right here, where we can write an equation. Where again, if I just sort of break it down, terrible. That this is 20, this is 12, and what is this side down here? X plus 5. Right. So in other words, it would be, again, I'm probably not going to finish this one, but because I think we just did one like it. But the idea is that x plus 5 squared plus 12 squared equals 20 squared. Make sure we FOIL. Make the x squares actually will cancel out, and then you would end up solving and be able to get x. Okay. And again, a lot of people might do something like 13 squared plus x squared. Remember, that's not a right triangle, right? So I had to look for a right triangle. There were actually 3 in here. There's the left one, like sort of, this one, and then of course the larger one that I just redrew over there. So it ended up just being one of those. And again, so if you have that equation, make sure you write that down. Make sure you can solve that. Again, that would be good practice anyway to solve. All right, 21 on 5.8. Oops, 21. Where's the wrong one? 21. What? Oh, this one. All right, I mean, this is very, very similar. I mean, I talked about it already a lot, but we'll just, the idea is that it's an equilateral triangle. So I'm going to draw that 60, 60, 60, right? Except it gives me a height of 30, right? So that makes it a 30, 60, 90, where this height is 30. So again, I'm just going to now like the height itself is 30, not 30 degrees. That might be confusing. So if I redraw this, again, I'm just going to redraw it over here just because I have some space, right? So the idea is that I want to find, I need to find the perimeter, which means need to find the side. So if this right here is 30, and this is 30 degrees, and this is 60 degrees, and that was 90 degrees, um, then uh, then if I label my sides, right, oops, that's the same color. If I label my sides now, opposite my 30 is S, opposite my 60 is S root 3, and this is 2S. Now I end up with, oh, well, S root 3 equals 30. So I divide S equals 30 over root 3. Now we got to rationalize. So root 3 over root 3 in this case. So 30 root 3 over 3, which is just 10 root 3. Right? All that simplifies to 10. So S right here is 10 root 3. So that's this side. This side was 30. And then 2S, well, 2 times 10 root 3 is just 20 root 3. So now I pretty much have everything I need, right? If I wanted the perimeter, it would be 10 root 3 plus 20 root 3 plus 30. So it would be 30 plus 30 root 3. Right, 30 plus 30, 30 root 3 was the perimeter. The area would be a little different. It would be 1/2 the base, which is 10 root 3, times the height, which is 30. That's right, not right. Okay, because remember, it actually asked for what I just did was wrong. Okay, so for both of them. Because, and again, this is actually a very common mistake that I made. And it's because I redrew this triangle, right? But the question asked me for the height, or sorry, the area and perimeter of the equilateral triangle, right? So if I sort of just think about what the equilateral triangle is, well, this side is like this is 20 root 3, this is 20 root 3, and this is 20 root 3, right? So the actual perimeter of this one is 60 root 3. All right, the perimeter of this triangle was the one that I said, but that's not what it asked for. It said, hey, find me. I'm using a 30, 60, 90 to try to find the side, then using the side times 3 because it's the same, right? It's equilateral. Okay, so the perimeter is 60 root 3. And now the area is going to be 1/2 the base, which is 20 root 3, times the height, which they gave me, which I already was down there, but it's 30, right? So they gave me that this was 30, 30. So times the height, which is 30. So that's my area. right? And so 20 times 30 is 600, divided by 2 is 300, so 300 root 3, and then wherever the units are, I don't know, I'm not sure what they are, they're down there, but that's how we would end up looking. All right, so hopefully that helped. Those two questions at the end, those were good questions. Again, be careful, because if it says like find the area of an equilateral triangle, then it wants the area of that equilateral triangle, not the area of this thing, right? If it says find the perimeter of the equilateral triangle, it's the perimeter of the equilateral triangle. We're using a 30, 60, 90 triangle possibly, or 45, 45, 90 triangle possibly to find things. But if it like, again, if it said find the area of a square with a diagonal of 12, right? Well, you would use the 12 as a, in the 45, 45, 90 triangle situation to find what the side was, 6 root 2, and then using the side to find the perimeter of the square, right? So it'll be 24 root 2, because it's just 6 times 4, 6 root 2 times 4, I should say. And then the area would be, well, 6 root 2 squared, which is just 72, right? So it's like area perimeter. The point is that, again, depending on what it asks for, you need to go with that. So if it says find the area of a square, well, yes, you're using a 45, 45, 90 to find the side of a square, which then with the side you can find the area and perimeter. Same thing with the equilateral triangle. You're using the 30, 60, 90 triangle to find the height or find the side of the equilateral triangle, or sorry, of the 30, 60, 90 triangle, which in turn helps you deal with the whole triangle, the whole equilateral triangle. All right, sound good? All right, sounds great. Thanks for sticking on. If you have any questions, feel free to shoot me a remind or email. Otherwise, I am going to leave now. All right. I'm on to you though. Geometry later. Boom.